3.1, this is about exponential functions. So what is an exponential function? All exponential functions can be written in the form a times b to the x, where b is bigger than 0, but it can be 1. Those are exponential functions. We are going to focus on one specific exponential function, e to the x. So base e to the x. E, you know what e is about 2.7. 2.7. And what I'm going to do here, I'm going to graph this x, y. So to graph this, I'm going to use the t-chart. So one value comes in mind, take x0. E to the 0, any number to 0 is 1. Take 1. E to the first power is about 2.7. E to the negative 1, x equals negative 1. It's e to the negative 1, which is 1 over e. 0 point something. If you do 2 here, e squared, and put on the calculator, will give you 7 point something. So 0, 1, that's 0, 1. 1 and 2.7. Negative 1 and something. 2 and 7 something. That's the graph. Is that okay? So here we got the graph, this exponential function. I think you hear a lot in the news or somewhere you read an article saying, you know, the population has a exponential growth. Exponential growth, like it's growing really fast, as you can see. It's from left to right, goes up. That's called exponential growth. What we are interested to do here is apply this to calculus. So the first thing is, if we have e to any function f of x, what would be the derivative for that? Derivative for that is the derivative of the exponent times itself. That's the formula to find the derivative of exponential function. So how are we going to find the derivative for this one? Watch. Y prime is, the formula says you find the derivative of this, which is 3 times itself. Try to find the derivative of this. Try to find the derivative of this. So this one is the derivative of the exponent, which is 2x times itself. Derivative of this, negative 1 times itself. To practice more, I'm going to write more of them. E to the x cubed, e to the x, e to the 5x, x squared e to the x, 3/2 e to the 4x, e to the x over x cubed. Now, y prime is what? Y prime is the derivative of this 3x squared times itself. That's what some of you got. For the next one, what's the derivative of ex? It's ex, right? It's the derivative of the top 1 times itself. Derivative for the next one is 5 itself How about the next one? What do we use here to find the, do we find the derivative for each one of them and multiply them out? Thank you. Someone said product rule. Use product rule because we have a product of two functions. So y prime would be the derivative of the first one times the second plus the first one times the derivative of the second. So what do we get here? Y prime is 2x times this plus this times ex, because the derivative of ex. Get to know it really well. For the next one, y prime, keep the constant out. We just find the derivative of this, which is 4 times itself. By 2, 1 by 2, 2. That's 6e to the 4x. Next one, we use quotient rule here. Quotient rule. So what's quotient rule? Quotient rule says you take the bottom one times the derivative of the top minus derivative of the bottom times the top over the bottom one square. So that gives us x cubed. Derivative of ex is ex minus 3x squared ex over x to the 6. One thing interesting about this, if you look in the back of the book, assuming this is a question in the back, you're not going to find this as an answer because on the top you can factor x squared out, and that will leave e to the x minus 3 e to the x over x to the 6. Then we can reduce here. The x squared cancels with 2 copies. That will leave 4 copies. If you like take ex, you can. That will leave x minus 3. This would be the answer. I can give you more examples if you want to try. X cubed e to the 2x. And then y equals e to the 3x over x squared. Try both of them. Let's go over them. First one, we use product rule. Derivative of the first one times the second plus the first one times the derivative of the second. Y prime is 3x squared e to the 2x plus, this stays the same, derivative of e to the 2x is 2e to the 2x. Here we use quotient rule. Use quotient rule as I did in the previous example. Y prime, if you want to remember, recall u over v, y prime for quotient rule, it's vu prime minus v prime u over v squared. This is the quotient rule. So you take the denominator times the derivative of the numerator minus derivative of the denominator times the numerator. So here you get 3e to the 3x minus 2x e to the 3x over x to the 4th. We may factor out x and e to the 3x. That will give us 3x minus 2 over x to the 4th. E to the 3x, 3x minus 2 over x to the 3rd. Anyone has any question about this? Try this one. There's another one here. Another one to try. We got y prime is the derivative of the top, like this, times itself. What's the derivative of e to the x? Is itself. You can leave it like this, or you can write it, because they have the same base, e. We add the exponents, x plus e to the x. For the next one, it's more tricky. What we need to do here is to rewrite it first as 1/2. Y prime, bring the 1/2 down by the power rule or the chain rule. Subtract 1 from the top, becomes negative 1/2 times the derivative of u by the chain rule. So y prime equals, I don't like to see negative exponents, so we're going to bring it down as positive 1/2. Keep the 1/2 up there. And the derivative of e to the x is e to the x plus 0. So the 1/2 can go down as 2 down there. And this is the square root. For the last one, the derivative of this is 4x cubed minus 5e to the 5x minus 0. Next one, find the slope of the tangent line to the graph of this function at the point 0, 1. How do we find the slope? Well, the slope is defined as the derivative of the function at that x value. So again, y equals e to the 3x. Y prime is 3e to the 3x. That's what y prime. If we evaluated it at x equals 0, e to the 3 times 0, which is 3. That would be the slope of the tangent line. Quick application related to exponential growth and decay. Let's say I don't know, if something that it can be modeled t years after 1995 by a of t equals 2.43 e to the 0.18t. Could be like bacteria growth, population growth, anything. This is just the model for it. So what would be the total number in 2009? In 2009, and let's say that's counting in bit by billions. This is easy to do. So from 1995 to 2009, that's how many years? 14. Let's say t is the years time. So this means we just need to find a of 14, not 13, 14. 2.43 e 0.18 times 14. Let's see, we'll put that on the calculator. That gives us 30.20 billion. Part B, what is the rate at which spending on organic food was growing in 2006? So this is about a model for spending the money on organic food. So remember again, a of t was given 2.43 e 0.18t. So rate means derivative, a prime. How do you find the derivative of this? Well, you keep the constant out. Derivative of this is the derivative of the top, which is 0.18 times itself. And they want us to find it in 2006. So from 1995 to 2006, that's 11 years. So then we need to find a prime at 11, 2.43 times 0.18 e to the 0.18 times 11, and put that in the calculator. That gives me 3.17 billion per year. If that's spending, that would be in dollars then. Dollars. And one last thing. We graphed earlier y equals e to the x, if you remember. It was this. How do we graph y equals e negative x? Negative x means make x negative x. So that's a reflection about the y-axis. So reflect this graph about y-axis. How about y equals negative e to the x? Negative e to the x, what we do, we reflect e to the x about the x-axis. That's how I got that graph. Just reflect it down. And the last one, e negative x minus 2. Usually anything comes after ex plus or minus b. This part here, y equals plus or minus b, is called horizontal asymptote. Horizontal asymptote. So how is that done? We graphed e to the negative x earlier. We said it's a reflection about the y-axis, so it was like this. But in this case, what we have y equals negative 2x minus 2. That's a horizontal asymptote. So this point is going to go down 1 to 2 steps.